ABCD is a trapezoid. So, see that there? Whose diagonals AC and DB, or BD, intersect at point E. That's right there. If vector AB, so that's this one, is 2/3 of vector DC, well, that tells us that these two must be parallel, which, since it's a trapezoid, that makes sense. So AB and DC are parallel. This one's 2/3 of this one. Given that that's true, we want to prove that AE is 3/5 of AB plus 2/5 of AD. So this is not a proof right now, just kind of seeing what's going on. We want to show that this vector is the sum of, what is it, about 3/5. So that's about, I don't know, there, and 2/5 of this one, so that's about there. So if you translated that over there, you get that. So this plus this is equal to that, which looks right? Like you can see that right there. So just kind of to see what's going on, that's what's going on. So the question is, how are we going to prove it? Well, one thing you might notice right away is that you have similar triangles. Triangle A, B, E is similar to triangle ABE, similar to triangle CED. And I'm not going to go through a full derivation of why it's similar. You should actually write what I'm about to say down, but this angle is equal to this angle because they're opposite angles, and this angle is equal to this angle because these two lines are parallel. And I don't know what you would have done in grade 9. You might have called it the Z pattern, right? The interior angles in a Z pattern, where the top and bottom are parallel. Those angles are equal. You might have called it interior angles theorem. I don't know. And then this angle and this angle are equal for the same reason, right? It's just the other way is that. So by angle, 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 because all three angles have to be equal. So why is that important? Well, what do we know about similar triangles? One, we know all the angles are equal, so how we show they were similar, but we also know that the sides are proportional. And that's exactly what this thing right here is telling us. It's telling us what that proportion is. It's telling us that AB is 2/3 of DC. So the proportion is 2/3. All these sides should be 2/3 of these sides. So if AB is 2/3 of DC, AB 2/3 of DC, that means that, for example, AE, therefore, AE vector is 2/3 of its corresponding side, which would be EC. And similarly, say DE is 2/3 of EB. Oh, sorry, I wrote that backwards, right? It's the other way around. Let's just erase that. Whoops. It's the smaller vector is 2/3 of the bigger vector, so let's say BE is 2/3 of ED. Okay, so we know that. Now let's go back to what we're trying to prove. We're trying to prove that AE is something. Well, this tells us that AE is something, right? It tells us that it's 2/3 of EC, which is not what we're trying to prove, but it's something. So let's write that down again. So AE is 2/3 of EC. So what would be nice if we could express EC now in terms of something and get it, get A and B in there, and then maybe everything will work out. So how could we express EC differently? Well, maybe we could express EC as, I don't know, how about ED times d plus dc, right? This vector is equal to this plus this. So 2/3 of ed plus dc. Alright, well, that's not bad. Why might that help? Well, notice we're trying to get it in terms of AB and AD, right? That's what we want to prove. Well, one of these vectors, DC, right, this vector here, I know in terms of AB, I know it's, I know this one's 2/3 of this one, which would mean this is 3.5 times that, right? 2/3 multiplied by 3/2, you get 3/2. So I could express DC is equal to 3/2 AB, which would be nice. I'll put that into there because then I'll have an AB, in this equation, which is kind of what we. But what about this ED, right? We still need to get an AD in terms of it, so maybe we could express ED in terms of AD. So what is ED equal to? ED, this vector here, remember we want to express it in terms of this one. Oh, well, ED is equal to EA plus AD. So what do we say? ED is equal to EA plus AD. So let's sub these two things into this equation. So ED equals EA plus AD vectors. So that's that first one. Plus DC was 3/2 AB. Alright. So we've got it in terms of AB, which is good, we wanted AB. AD, which is good, we wanted AD. But now EA, I didn't want EA. Although notice this, EA, we're actually trying to prove something with AE. Well, I can express EA as negative AE. So let's do that. Sorry. Let's go E for erase, B for brush. So AE is equal to 2/3 of, now we're going to change EA to negative AE plus AD plus 3/2 AB. Now let's expand this bracket. 2/3 negative AE plus 2/3 AD plus 2/3 times 3/2 is 1, so plus AB. And that's all equal to AE. So notice now we have AE and AE, so let's group them on this side of the equation. So AE plus 2/3 AE is equal to 2/3 AD plus AB. So now I can add these, right? AE plus 2/3 AE, it's like terms. So really there's a 1. 1 plus 2/3 would be 5/3 AE is equal to 2/3 AD plus AB. And then if we want to get AB by itself, we'd multiply both sides of the equation by 3/5. So AE equals 3/5 times 2/3 AD plus AB, and now just expand. So AE is equal to 3 over 5 times 2 over 3. That would be 2 over 5 AD, well that's good, plus 3 over 5. AB. I don't know why I put the bracket there. Which, going back, oh, I have it backwards, but whatever. It's the same, right? Therefore, we've proved it.